Have you ever really stopped to think about how your car actually works? I mean, how thousands of pounds of metal and plastic, powered by tiny, controlled explosions, can move you down the road so smoothly? Well, today we're going to dive into that, because the journey from the engine's power to the actual pavement is a true masterpiece of engineering.
I mean, really think about it. How does all that force translate into controlled motion? How does a car not just sit there and spin its wheels in place? The answer is way more complex and, honestly, way more interesting than you might imagine.
And it all happens thanks to a team of 4 crucial components, these unsung heroes, all working together perfectly. So we're going to follow that flow of power, step by step, from the very core of the car, right down to that tiny little patch of rubber that's actually touching the asphalt.
Okay, let's start with what is literally the backbone of this whole operation, the axle. This is where the story of getting power to the ground and holding the entire car up really begins.
So here's the key thing to get. The axle is doing 2 massive jobs at the exact same time. It's not just some dumb bar holding the wheels apart. Nope. It's the structural support system holding the car up, and it's the power delivery mechanism. But, not all axles are created equal. And there's a really important distinction here. A live axle is the one actually doing the work. It's actively spinning the wheels. Think about the rear axle on a rear-wheel drive pickup truck. A dead axle, on the other hand, is kind of just along for the ride. Its only job is to hold up that end of the car like the front axle on that very same truck. And we can go even deeper. The axles that actually transmit power have different designs depending on the job. Your everyday passenger car? It probably uses what's called a semi-floating axle. That means a single shaft has to do 2 things at once: handle the twisting force, or torque, and bear the car's weight. But on a huge, heavy-duty truck, they use a much beefier, full-floating design. Here, the axle shaft only has to deal with the twisting force. The weight is supported by a separate housing, which makes it way, way stronger for those heavy loads.
Okay, so we've got this big, powerful, rigid axle spinning away. But how do you get a wheel to spin freely on the end of it, for millions and millions of revolutions, without grinding itself into dust? Well, that's where our next hero comes in, the smooth operator.
The wheel bearing is, no joke, one of the most incredible, high-stress parts in your entire vehicle. It's like this magic little interface between the parts that are supposed to stay still, like the axle housing, and the parts that need to spin like crazy, like the wheel. And just look at the job it has to do. It's not just about spinning. It has to support the car's weight pushing down. That's called a radial load. But it also has to fight off the immense side-to-side forces you create every single time you take a corner. That's the axial load. And on top of all that, in modern cars, this little component is smart. It's where the sensors for your anti-lock brakes live. Just incredible.
Now, bolted directly to that smooth spinning bearing is the foundation for our next component, the wheel itself.
It seems pretty simple, right? But a wheel has a few key jobs. You've got the rim, which is that outer lip that creates an airtight seal with the tire. You have the spokes, or the disc, which provides all the structural strength. And then you have the hub, which is where it all bolts onto the car.
So why do people spend extra money for alloy wheels? It really just comes down to one thing: weight. Steel is super cheap and tough, but man, it's heavy. Lighter alloy wheels reduce something called unsprung weight, which lets the suspension react way faster to bumps, and that improves handling. Plus, less weight for the engine to spin up helps with acceleration and can even improve your fuel economy.
All right, here's a concept that is hugely important, but a lot of people overlook it: offset. It's not just about how cool the wheel looks, it's a critical geometric measurement. And if you get this wrong, you can mess up everything from tire clearance to suspension wear and even just the basic feel of the car.
Almost every modern car you see has a positive offset. All this means is that the surface where the wheel bolts onto the car is pushed out toward the street. This design tucks the wheel neatly inside the fender, which is great for aerodynamics and clearance.
And a negative offset does the exact opposite. It pushes the bulk of the wheel outward, away from the suspension. This is what gives you that classic deep dish look you see on a lot of off-road trucks or custom cars. But be careful, because getting this measurement wrong can seriously mess up a car's handling.
And that brings us from the axle, through the bearing, to the wheel, and finally, to the single most important part of this entire system, the final touch point, the tire.
Just let that sink in for a second. Not the engine, not the brakes, not even the airbags, the tire. Why? Because everything else your car does, accelerating, braking, turning, all of it ultimately has to be translated to the road through 4 small patches of rubber. If the tires fail, everything else fails.
A modern tire is basically a high-tech sandwich. You've got the internal fabric, the carcass, that gives it its shape. Then you have steel wire beads that lock it onto the wheel rim. You've got steel belts under the tread for stability. And finally, you have that all-important tread that actually grips the road.
And all that info is written right on the side. You know that code that looks like gibberish? It's actually the tire's whole resume. 205 is how wide it is in millimeters. 55 is the height of the sidewall as a percentage of the width. R just means it's a radial tire. 16 is the wheel size it fits. And that last part, 91W, tells you how much weight it can carry and how fast it can safely go. See? Not so confusing.
So why is that tread design so absolutely critical? Well, it's because of this: hydroplaning. This is what happens when those grooves in your tread can't pump water out from underneath the tire fast enough. The tire literally lifts off the pavement and starts surfing on a thin film of water. And at that point, you have zero control. This is exactly why worn-out tires are so dangerous. 4. That's it. After all that complex engineering, the axle, the bearing, the wheel, the tire, it all comes down to 4. 4 little contact patches, each one about the size of your hand, that connect your 2-ton vehicle to the planet. That's it.
From that spinning axle all the way to the flexing tire tread, it's just this incredible system that we rely on every single day. The journey from power to pavement is this quiet symphony of physics and mechanics. So the next time you're behind the wheel, just take a second to appreciate that incredible engineering happening right beneath your feet, turning raw power into controlled, effortless motion.